Hello students. Now in this video we will start the new topics, that is a definite integral. If you have completed indefinite integral, that is a chapter number 3, then it is easy to understand this chapter. In this chapter we will learn the properties of definite integral. The first topics that is a definite integral as a limit of sum is omitted for this year. Therefore, I am starting with the exercise 4.2 and the properties of definite integral. I will explain all the properties, and question number 1 from exercise 4.2. I will cover all the 15 examples. And now let us start. Now the first is fundamental theorem of integral calculus. It's very important. Let f be the continuous function defined on closed interval ab, and if the integral of f of x into dx is equals to g of x plus c, that is the integral of f of x is g of x plus c, then integral lower limit a and upper limit b, integral lower limit a to upper limit b f of x dx is equals to, what's the integral of f of x is g of x plus c, and this is the lower limit a and the upper limit b. Then we first substitute the upper limit minus lower limit. What's the upper limit? Upper limit is b. That is, the x is replaced by b. Therefore, g of b plus c minus g of a plus c. If you open the bracket, then you will get g of b plus c minus g of a minus c. Here plus c and minus c get cancelled and you get g of b minus g of a, and thus integral a to b f of x dx is equals to g of b minus g of a. In integral lower limit a to b f of x dx, a is called as a lower limit and b is called an upper limit. Now let us discuss some fundamental properties of definite integration. These properties are very useful in evaluation of the definite integral. Now, first property is very important, that integral lower limit is a, upper limit is b, f of x dx is equals to. Now we will define what is the integral of f of x is equals to g of x plus c. Integral of f of x dx is equals to g of x plus c. Therefore, integral lower limit a upper limit b f of x dx is equals to, in bracket, g of x plus c, lower limit is a, upper limit is also a. Therefore, upper limit minus lower limit, that is upper, if you substitute, replace x by a, then you will get g of a plus c minus g of a plus c. Open the bracket, then you will get g of a plus c minus g of a minus c. Here g of plus a and minus a get cancelled, plus c and minus c get cancelled, and hence the integral lower limit is a, upper limit is also a, f of x dx is equals to 0. Value of this definite integral is 0. Now see this, one more examples again, that is integral 1 to 3 x dx. What is the integral of x? It's x square upon 2. What is the lower limit is 1, upper limit is 3. Substitute the upper limit minus lower limit. That is the 3 square upon 2 minus 1 square upon 2. 3 square is a 9 by 2 minus 1 upon 2. And what is here? 8 upon 2, that is equals to 4. And if you change the limits, that is a lower limit is upper and upper is lower. Then what about its value? That is the integral 3 to 1 x dx. It's x square upon 2, lower limit is a 3, upper limit is 1. Upper limit minus lower limit, that is the 1 square upon 2 minus 3 square upon 2. Then you will get 1 upon 2 minus 9 by 2, and that is equals to minus 4. If we change these limits, then the value of integration changes by the sign. The same property we will evaluate here. That integral a to b f of x dx is equals to minus integral b to a f of x dx. If we change the limit, the function is same, then the value of definite integral changes by the sign only. Now again we will define let the integral of f of x dx is equals to g of x plus c. Therefore, integral a to b f of x dx is equals to the integral of f of x is g of x plus c. Lower limit is a, upper limit is b. Substitute upper limit minus lower limit. That is the g of b plus c minus in bracket g of a plus c. Open the bracket, then you will get g of b minus g of a. Take the minus sign as common, then you will get g of a minus g of b. But what about this? याची value काय असणार आहे? G of a minus g of b is nothing but the integral lower limit b upper limit a f of x dx, and thus that is the integral a to b f of x dx is equals to minus integral b to a f of x dx. Now we see the next property number 3. This property, if you see this property, that is the integral a to b f of x dx is equals to integral a to b f of t dt. The function is same, limits is same, but only the variable change. If we change the variable, then it doesn't changes the value of that definite integral. Variable कोणताही घेतला तरी चालतो, function तो आहे, limit पण तेच आहे, तर its value remains the constant. Now we'll see the first one by one. That is, let integral f of x dx is equals to g of x plus c. Therefore, the LHS integral a to b f of x dx is equals to g of x plus c. Lower limit is a, upper limit is b. Substitute upper limit minus lower limit. That is a g of b plus c minus in bracket g of a plus c. Open the bracket and then you will get g of b minus g of a. This is expression number 1. Now the next we will see the RHS. See this RHS. Integral a to b f of t dt. And that's why that is the integral a to b f of t into dt. Here only the variable is changed. What is the integral of f of t is a g of t plus c. Again the lower limit is a, upper limit is b. Substitute upper limit minus lower limit. That is g of b plus c minus g of a plus c. Open the bracket, g of b minus g of a. This is the second one. And from the 1 and 2, the values of this definite integral is equals. That is the g of b minus g of a. Integral a to b f of x dx is equals to g of b minus g of a. This is 1. And the integral a to b f of t into dt is equals to g of b minus g of a. This is 2. Therefore, from 1 and 2, integral a to b f of x dx is equals to integral a to b f of t dt. That the definite integration is independent of the variable. You can take any variable x, t, y, z, w. If functions are same, limits are same, its value doesn't changes. Now the next property, that is the property number 4. Integral a to b f of x dx is equals to integral a to c f of x dx plus c to b f of x dx, where c lies between a and b and c belongs to, that is, a c belongs to closed interval a and b. Where c is the intermediator between the a and b. It's very, again we'll define let f of x is equals to g of x plus c. Now consider the RHS. That is integral a to c f of x dx plus c to b f of x dx. Now we have defined that the integral of f of x dx is equals to g of x plus c. What is the integral of f of x is a g of x plus c. Lower limit is a, upper limit is c. Plus g of x for the second integration. Integral of the f of x is g of x plus c. Lower limit is c, upper limit is b. Substitute the value. Upper limit, that is a c. X is replaced by c, that is a g of c plus c minus g of a plus c, closed bracket, plus again upper limit g of b plus c minus g of c plus c. Open the bracket and then you will get, that is a plus c and minus c get cancelled, plus minus c and plus c get cancelled. And what overall you will get, that is a g of plus c and the g of minus c get cancelled, and you will get g of b minus a g of a. But the g of b minus g of a is nothing but the, that is a, in the closed bracket, g of c plus c, where the lower limit is a, upper limit is b, and this is nothing but the integral a to b f of x dx. That is nothing but our LHS. This is our LHS, and hence LHS is equals to RHS, and thus integral a to b f of x dx is equals to integral a to c f of x dx plus c to b f of x dx, where c lies between a and b. Now see the next property, very important property. Integral a to b f of x dx is equals to integral a to b f of a plus b minus x dx. That is, let f of x is equals to g of x plus c. प्रत्येकदा प्रॉपर्टी प्रूव्ह करायला आल्यानंतर मी प्रत्येकदा असं म्हणतो की आन्सर तिथेच दिलेलं आहे. आन्सर हॅज बीन गिवन इन दॅट प्रॉपर्टी. Means what? You have to consider this RHS. Consider the RHS integral a to b f of a plus b minus x dx. Put a plus b minus x is equals to t. That is, x is equals to a plus b minus t. That is, whatever that here given, subput as that is equals to t. Therefore, x is equals to a plus b minus t. Differentiate on both sides. Then you will get differentiate here minus dx is equals to dt. The derivative of a and b is 0. They are arbitrary constant. Therefore, minus dx is equals to dt. And it implies dx is equals to minus dt. Now we'll change the limit. We have substituted a plus b minus x is equals to t. That is, now put first of all lower limit is a. That is, a t is replaced by, the x is replaced by a. Then what you will get? That is, a plus a and minus a get cancelled. Then you will get t is equals to b. Always when we change the variable, ज्या वेळेस आपण व्हेरिएबल चेंज करत असतो त्या वेळेस आपल्याला लिमिट देखील बदलायची असतात. Whenever we change the variable, at that time we want to change the limits also. In this case, we have new variable as a t. Our original variable is x. Now put here x is equals to a, plus a minus a get cancelled. You will get the lower limit t is equals to b. What about the upper limit? Now again substitute here t is x is equals to b. Again plus b minus b get cancelled, and you will get the upper limit as a. Therefore, our integral will become, this is our integral. This integral, that is, a lower limit was b, upper limit is a. What about here? F of a plus b minus x. The value of a plus b minus x is t, which is f of t. What about the dx? Dx is minus dt. Take minus sign as common. Then what about it? Again, just we have learned the property that if we change the limits, upper limit to lower and lower limit to upper, it absorbs the negative sign. In this case, we will change the limits. आपण याचे limits change करणार. That is, the lower limit will be upper limit and upper limit goes to lower limit. Therefore, we have written here integral a to b f of t dt. That's I have written here the property. And again, I am applying the one more property, that is a change in the variable. That is, I am taking the here variable as x. T is replaced by x. The value of the integration doesn't changes. Therefore, integral a to b f of x dx as a definite integral is independent of the variable, and this is nothing but our LHS, and thus LHS is equals to RHS. That is the integral a to b f of x dx is equals to integral a to b f of a plus b minus x into dx. Now the next property number 6. This is also property very important. Always we solve too much examples we solve by using this property. बरेच एक्झाम्पल्स असे आहेत की या प्रॉपर्टीच्या साहाय्याने आपण सॉल्व्ह करत असतो. व्हेरी इम्पॉर्टंट प्रॉपर्टी. इंटिग्रल a to b इंटिग्रल 0 to a f of x dx is equals to integral 0 to a f of a minus x dx. Let f of x, again the integral of f of x dx is equals to g of x plus c. Now consider the RHS. Again I will say that the answer is given in this property. प्रत्येकदा मी असं म्हणत असतो की या प्रॉपर्टी मध्येच आन्सर आहे. का की सेम आधीच्या प्रॉपर्टी प्रमाणे RHS कन्सिडर करणार आणि a minus x ला आपण t सबस्टिट्यूट करणार. Consider the RHS integral 0 to a f of a minus x dx. Now put a minus x is equals to t. That is, x is equals to a minus t. Differentiate again this will change. That is, a derivative of a is 0 because it is a constant. Derivative of minus x is minus dx and t is a dt. Therefore, dx is equals to minus dt. As now will change its a limit also. That is, the lower limit is 0. Put x is equals to 0 here. Then what you will get? T is equals to a. Then you will get the lower limit as a. What about the upper limit? Put x is equals to a here. A minus a is 0. Therefore, upper limit is 0. Therefore, As x varies from 0 to a, t varies from a to 0. Lower limit, we have substituted 0, t is equals to a. Upper limit, substitute a, you will get t is equals to 0. Therefore, the limits varies from a to 0. Now our integral will become, therefore I will become integral. Lower limit is a, upper limit is 0, a 0. What about the value of a minus x? A minus x is t, therefore it is f of t. What is the value of dx? Dx is minus dt. Here is a minus integral a to 0 f of t dt. Now we can absorb again this negative sign. That is a 0 to a f of t dt. That is by using this property. If we change the limit, then the value of that definite integral changes. Again, by using the definite integral as a independent of the variable, that is t is replaced by x, integral 0 to a f of x dx, and this is nothing but the LHS, and thus this is very important property. Integral 0 to a f of x dx is equals to 0 to a f of a minus x dx. Now the next property, that is property number 7. 0 to 2a f of x dx is equals to 0 to a f of x dx plus 0 to a f of 2a minus x dx. Now we'll prove this property in separate two forms, that is I1 and I2. Now consider RHS. That RHS, that is the integral 0 to a f of x dx plus 0 to a f of 2a minus x. And we'll solve this RHS, and that's equals to integral 0 to 2a f of x dx. The first integral treated as I1 and second integral we'll treat as I2. Now we'll first consider that is the I2. Here I2 is equals to integral 0 to a f of 2a minus x dx. Again the answer is given here, substitution is given here. म्हणजे प्रश्नातच उत्तर दिलेलं आहे. हेच इंटिग्रल आपण सॉल्व करायचं. Yes, now we'll solve that. Put substitution. बऱ्याच वेळा substitution काय घ्यायची? हा प्रश्न आहे. Here the 2a minus x is equals to t. What about the x? X is equals to 2a minus t. What about its a dx? Differentiate. 2a is a constant, its derivative is 0. Minus 1 dx is equals to 1 dt. Therefore dx is equals to minus dt. Now we'll change the limits. Upper limit and lower limit. Now first put x is equals to 0. Then you will get t is equals to 2a. Therefore the values of the t varies from 2a. Now next upper limit is a, put x is equals to a. Then you will get 2a minus a. That is a t is equals to a. Therefore x varies from 0. I will again repeat here. As x varies from 0 to 2a, t varies from 2a to a and not 0. Therefore I is equals to integral lower limit is 2a and upper limit is a f of t in bracket minus dt. Now we'll take the minus sign as a common. Then you will get integral 2a to a f of t dt. Now again we will absorb the negative sign by using this property. If you change the limit upper to lower, lower to upper, negative sign will be absorbed. That is integral a to 2a f of t dt. Again we'll apply here the change in the variable property, integral a to 2a f of x dx. And therefore what is here? The integral we have started here, the integral 0 to a, that is the I2, that is equals to, therefore our integral 0 to a f of 2a minus x dx is equals to a to 2a f of x dx. That is, we have defined this. This is our I2, 0 to a f of 2a minus x. The value of this I2, that is equals to a to 2a f of x dx, and therefore this is I1 and this is I2. That is the 0 to a f of x dx is equals to 0 to a f of 2a f of 2a minus x dx is equals to 0 to a f of x dx plus 0 to 2a f of x dx. Again by using the property, that is 0 to a to 2a, and that's nothing but 0 to 2a f of x dx, which is our LHS, and hence integral 0 to 2a f of x dx is equals to integral 0 to a f of x dx plus 0 to a f of 2a minus x dx. And the next property number 8, integral minus a2 plus a f of x dx is equals to 2 times integral 0 to a f of x dx. If f of x is equals to even function, that is integral minus a2 plus a f of x dx. If the f of x is even, then the 2 times 0 to f of x dx. And if f of x is odd, then the value of this integration, that is integral minus a2 plus a f of x dx, that is equals to 0. Now what is meant by the even and odd function? You have learned in the 11th standard. Even function means what? F of x as even function if f of minus x is equals to f of x. F of x is equals to x square. This is the even function. That it absorbs the negative sign. F of x is equals to x cube. It is odd function. That is f of minus x is equals to minus f of x. These are the definitions of the even and odd function. Again, we apply here the one more property. That is the element c, which is 0 here, lies between minus a and the plus a. That is, this integration can be written as integral minus a2 plus a f of x dx is equals to integral minus a to 0 f of x dx plus 0 to a f of x dx. We want to evaluate this integral. This is our motto to solve this, because we want to prove that the 2 times integral 0 to a f of x dx. That is, we want to change this integral 0 to a f of x dx. When it is even, then it will become 2 times 0 to a f of x dx. Now consider this integral. Now here the substitution is important. Definite integrationच्या प्रॉपर्टीज आपण जेव्हा सॉल्व करत असतो त्यावेळेस सबस्टिट्यूशन फार इम्पॉर्टंट आहे. मी ते काय सबस्टिट्यूशन्स घेतली पाहिजे, तर x is equals to minus t. Therefore dx is equals to minus dt. Now we'll change the limit. Put x is equals to minus a. Therefore the t is equals to a, x is equals to minus a. That is, minus a is equals to minus t. Then t is equals to a. Put x is equals to 0. Minus t is equals to 0. That is, that t is equals to 0. Therefore, here written as x varies from minus a to 0, then the t varies from a to 0. If we substitute again, I will repeat here. The limits are also very important. That is, put x is equals to minus a. Minus t is equals to minus a. T is equals to a. Put x is equals to 0. T is equals to 0. These are the limits. Therefore, our integral becomes I is equals to integral a to 0 f of minus t in bracket minus dt. Take the minus n again outside this integral sign. That is the integral a to 0 f of minus t dt. And we can again change the limit. Upper limit to lower limit, that is the negative sign will be absorbed. Integral 0 to a f of t dt, again by the change in the variable property, 0 to a f of minus x dx. And therefore the equation 1 becomes, which is the equation 1? This is the equation 1 becomes. What is the value of this integral? The value of this integral is the 0 to a f of minus x dx, f of minus x dx. And therefore integral minus a2 plus a f of x dx is equals to 0 to a f of minus x dx plus 0 to a f of x dx. Take the integral as a common, then you will get integral 0 to a in bracket f of minus x plus f of x dx. If the function f of x is odd function, that f of minus x is equals to minus f of x. And therefore the value of this integral will be 0. If we replace f of minus x as minus f of x, and its addition will be the 0. And therefore that integral will be 0. And if f of x is a even function, means what? F of minus x is equals to f of x. Then what will happen? This f of minus x is equals to f of x. F of x plus f of x, that will become 2 times f of x, and that's why 2 into integral 0 to a f of x dx. And hence this property is very important, that is integral minus a to plus a f of x dx is equals to 2 times 0 to a f of x dx if f of x is even function, and equals to 0 if f of x is odd function. And in this way we have completed all the properties of the definite integration. Now we'll start the exercise 4.2. Evaluate the first integral, that is integral 1 to 9 x plus 1 upon root x dx, and that is equals to integral 1 to 9 split up this x upon root 2 plus 1 upon root, x upon root x plus 1 upon root x dx. That is x upon root x, that is the root x, and root x 1 root x will get cancelled. You will get root x plus x raised to minus 1 upon 2 dx. And its integral is 2 by 3 x raised to 3 by 2 plus 2 into x raised to 1 upon 2. Lower limit is 1, upper limit is 9. Now substitute upper limit minus lower limit. That is 2 by 3 in bracket 9 raised to 3 by 2 plus 2 into 9 raised to 1 upon 2 minus, what about the next? That is a 2 by 3, 1 raised to 3 by 2 plus 2 into 1 raised to 1 upon 2. That is the upper limit minus a lower limit. Therefore here, that is a 9 raised to 2 by 3. 9 raised to 3 by 2 means what? 3 raised to 2. 2 get cancelled. 3 raised to 3, that is a 27. 2 by 3 into 27. 2 by 3 into 27. Then you will get 18. 2 into 3 is a 6 minus 2 by 3 minus 2. And if we add this, that is a 18 plus 8, that is a 6 minus 2, that is a 4, and 18 plus 4, 22 minus 2 upon 3, and that is equals to 64 upon 3, and hence I is equals to 64 upon 3. Now the next integration is, that is I is equals to integral, second integral is that is the integral 2 to 3 dx upon x square plus 5x plus c. That is a 2 to 3 integral dx upon, it's a factors of x square plus 5x plus 6 are x plus 2 into x plus 3. Now by using the partial integration, this is the integral of the form partial form, that is 1 upon x plus 2 into x plus 3, that is equals to a upon x plus 2 plus b upon x plus 3. That's 1 is equals to a into x plus 3 plus b into x plus 2. Put x is equals to minus 2, then you will get the value of a. That is 1, that is a minus 2 plus 3. Therefore, a is equals to 1. For b, put x is equals to minus 3. That is 1 is equals to b in bracket minus 3 plus 2. That is a minus 1. Therefore, b is equals to minus 1. Therefore, our integral become, that is I is equals to integral 2 to 3 dx upon x plus 2 into x plus 3. That is equals to 2 to 3 in bracket 1 upon x plus 2 minus, substitute the value of a and b. A is 1 here and b is a minus 1. 1 and minus 1. Now the integral of this is a log of x plus 2 minus log of x plus 3. Lower limit is 2 and the upper limit is 3. And substitute upper limit minus lower limit. Now see this here, the log of x plus 2 minus log of x plus 3. By using the property, we can write here log of x plus 2 upon x plus 3. Upper limit is 3, lower limit is 2. Substitute first of all upper limit minus lower limit. X is replaced by 3, that is a log of 3 plus 2, 5. 3 plus 3 is 6, minus 2 plus 2 is 4 upon 5. Now again there is a minus sign in between them by using again the property of the log. That is log of m minus m, that is nothing but the log of m upon n. That is a 5 by 6 upon 4 by 5. That is 5 by 6 into 5 by 4, and you will get, that is I is equals to log of 25 upon 24, and therefore the integral I is equals to log of 25 upon 24. Now the next integral is the integral 0 to pi by 4 cot square x dx, 0 to pi by 4. Now cot square x means what? Cosec square x minus 1. What is the integral of cosec square x? Is a minus cot x. Integral of 1 is x. Lower limit is 0, upper limit is pi by 4. Now again substitute upper limit minus lower limit. That is a minus cot of pi by 4 minus pi by 4 minus cot of 0 and minus 0. Cot of pi by 4 is 1. Here is a minus 1 minus pi by 4 and cot of 0. But the cot 0 is not defined. Therefore the integral does not exist since the cot of 0 is not defined. Now we'll see the next example. Here the example number 4, that is integral minus pi by 4 to plus pi by 4 1 upon 1 minus sin x dx. That is equals to minus pi by 4 to plus pi by 4 in bracket 1 plus sine x upon multiplied n and dy 1 plus sine x. Therefore, you will get to the numerator 1 plus sine x upon 1 minus sine square x. The limits are as it is, minus pi by 4 to plus pi by 4. 1 plus sine x is as it is, 1 minus sine square x is the cos square x. Now next split up this, that is integral minus pi by 4 to plus pi by 4, that is equals to 1 upon cos square x plus sine x upon cos square x, and that is 1 upon cos square means what? Sec square x. Sine x upon cos x and 1 upon cos means what? Sec x. By mistake here is a square sign, but it is a sec x. That is a sin x upon cos x is tan, and 1 upon cos means what? Sec x. What is the integral of sec square x? Is a tan x, and the integral of sec x into tan x into sec x is a sec x. Again the upper limit and the lower limit. Upper limit minus lower limit. That is a tan of pi by 4 plus sec of pi by 4 minus tan of in bracket minus pi by 4 plus sec of minus pi by 4. Tan of pi by 4 is 1, sec of pi by 4 is root 2. Minus in bracket tan of minus pi by 4 is minus 1, and the sec of minus pi by 4. That is the reciprocal of sec is a cos, and cos is positive in fourth quadrant. Therefore, sec of minus pi by 4 is root 2. Open the bracket, then you will get 1 plus root 2. Minus minus will become plus. Therefore, here is a plus 1 and the minus root 2. Plus root 2 minus root 2 get cancelled, and you will get 1 plus 1, and that is equals to 2. And hence the integral minus pi by 4 to plus pi by 4, 1 upon 1 minus sin x dx is equals to 2. Now problem number 5. Integral 3 to 5 1 upon in under root of 2x plus 3 minus in under root of 2x minus 3 dx. Now rationalize the numerator and the denominator. Multiply with the in root of 2x plus 3 plus in root of 2x minus 3 to the numerator and the denominator. Then you will get integral 3 to 5. That is 1 into root of 2x plus 3 plus root of 2x minus 3 is as it is. And this is the root of 2x plus 3 minus root of 2x minus 3 into in bracket root of 2x plus 3 plus root of 2x minus 3. That's nothing but the 2x plus 3 minus in bracket 2x minus 3. Open the bracket, plus 2x and minus 2x will cancel, plus 3 that will become 6. That is 1 by 6 integral 3 to 5. 2x plus 3 raised to 1 upon 2 plus 2x minus 3 raised to 1 upon 2 dx. And the integration of this, that is 1 by 6. 2x plus 3 raised to 3 by 2 upon 3 by 2 into 2 plus 2x minus 3 raised to 3 by 2 upon 3 by 2 into 2. Here 2 get cancelled, and you will get, that is a 1 by 6 in bracket 2x plus 3 raised to 3 by 2 upon 3 plus 2x minus 3 raised to 3 by 2 upon 3. Upper limit is 5, lower limit is 3. Substitute upper limit and lower limit, and at the same time take these 3 as common. That is 1 by 6 into 1 by 3, that is 1 by 18. Substitute, replace x by 5. That is a 2 into 5 plus 3 raised to 3 by 2 plus 2 into 5 minus 3 raised to 3 by 2 minus 2 into 3 plus 3 raised to 3 by 2 minus 2 into 3 minus 3 raised to 3 by 2. That is a 2 into 5, that is a 10 plus 3, that is a 13 raised to 3 by 2 plus 7 raised to 3 by 2 minus, that is 6 plus 9. 6 plus 3, that is a 9. 9 raised to 3 by 2 minus 3 raised to 3 by 2. What about here? 13 raised to 3 by 2 means what? 13 into root 3. 7 raised to 3 by 2, that is a 7 root 7. What about here? 9 raised to 3 by 2 means what? 9 into root 9. And 3 raised to 3 by 2 means what? 3 into root 3. What about here? Here 1 upon 18. 13 root 13 plus 7 root 7 minus root of 9 means what? This is a 3. 3 into 9, 27 minus 3 root 3. Therefore 13 root 13, 7 root 7 minus 3 root 3 minus 27. This is the answer. Now we'll see the next problem. Now see this problem number 6, integral 0 to 1 x square minus 2 upon x square plus 1 dx. I is equals to integral 0 to 1 x square minus 2 upon x square plus 1. X square minus 2 can be written as x square plus 1 minus 3. Now again split up this integral 0 to 1, that is x square plus 1 upon x square plus 1, that will be 1, minus 3 upon x square plus 1 bracket complete dx. Now the integral of 1 is x and the 3 upon x square plus 1. that is a 3 tan inverse of x. Lower limit is 0, upper limit is 1. Now substitute x is replaced by 1. Then you will get 1 minus 3 tan inverse of 1. Replace x by 0. 0 minus 3 tan inverse of 0. And therefore you will get 1 minus 3. What is the value of tan inverse of 1? Tan inverse of 1 is pi by 4. And hence the answer is 1 minus 3 pi by 4. Therefore I is equals to 1 minus 3 pi by 4. Now the problem number 7. I is equals to integral 0 to pi by 4 sine of 4x and sine of 3x dx. Now here we will apply the formula, that is a sine of a into sine b is equals to 1 upon 2 cos of a minus b minus cos of a plus b. Now here cos of a minus b, a is a 4x minus 3x is x, minus cos of a plus b, 4x plus 3x which is a 7x. Therefore 1 upon 2 integral 0 to pi by 4 cos of x minus cos of 7x dx. Integral of cos of x is a sine of x and integral of cos of 7x is a sine of 7x upon 7. 0 to pi by 4. And substitute the upper limit minus lower limit. That is replace x by pi by 4. That is a sine of pi by 4 minus 1 upon 7. Sine of 7 pi by 4 minus 0. And now the value. That is a sine of pi by 4 is a 1 upon root 2. What about the sine of 7 pi by 4? Sine of 7 pi by 4, it goes in a fourth quadrant and the sign is negative in fourth quadrant and its value is a minus 1 upon root 2, which you have learned in 11th standard. That is 1 by root 2 minus minus will become plus. Therefore, you will get 1 by root 2 plus 1 upon 7 root 2. Now, by adding this, now by using the LCM, that is multiplied, this 1 upon root 2 by 2 the numerator and denominator by 7. 7 plus 1 that will become 8 and therefore denominator is a 7 root 2. And hence the answer is 4 upon 7 root 2. And therefore the answer is a 4 upon 7 root 2. Now the next problem, integral 0 to pi by 4 in root of 1 plus sine 2x dx. Very interesting problem. 1 means what? Cos square x plus sine square x. And the sine 2x is 2 sine x into cos x. Now this is a perfect square. That is a cos of x plus sine x whole square. Now see this is our integral. I is equals to integral 0 to pi by 4 in root of 1 plus sine 2x dx. 0 to pi by 4 in root of cos of x plus sine of x bracket square. Bracket square and root sign get cancelled. You will get 0 to pi by 4 cos of x plus sine x dx. Okay. Now the integral of cos of x is sine x and sine of x is minus cos x. 0 to pi by 4. Now substitute upper limit minus lower limit. That is a sine of pi by 4 minus cos of pi by 4 minus sine 0 and the cos 0. Sine of pi by 4 is 1 upon root 2. Cos of pi by 4 is again the 1 by root 2. Sine 0 is 0. Cos 0 is 1. Open the bracket, plus 1 by root 2 minus 1 by root 2 get cancelled, and minus in bracket 0 minus 1 you will get 1, and therefore I is equals to 1. Now the problem number 9, I is equals to integral 0 to pi by 2, but in the textbook there is a pi by 4, but I had corrected it. That is pi by 2, integral 0 to pi by 2 sine of x raised to 4 dx, 0 to pi by 2 sine of x raised to 4 dx. Now sine of x raised to 4 can be written as sine square x bracket square dx, 0 to pi by 2. But what about the sine square x? Again by using the trigonometry that you have learned in the 11th standard. Sine square x means what? 1 minus cos of 2x upon 2 bracket square dx. Here is a bracket square, bracket square. Now what about here? 1 minus cos 2x upon 2. That is a 2 square means what? 1 by 2 square means what? Here is a 4. Take 1 by 4 outside this integral sign. That is 1 by 4, 0 to pi by 2 in bracket 1 minus cos 2x bracket square. Now open this bracket, that is a minus b bracket square. A square minus 2ab plus b square. Then you will get 1 by 4, 0 to pi by 2, 1 minus 2 cos 2x. What about the cos of cos square 2x? Again by using the trigonometry that you have learned in the 11th standard. 1 plus cos of 4x upon 2. Therefore 1 by 4, 0 to pi by 2, 1 minus 2 cos of 2x. Now again split up this, 1 upon 2 plus cos of 4x upon 2. Now integrate this, that is a 1 minus 1 plus 1 upon 2. That will become 3 by 2. What about here? Minus 2 cos 2x, minus 2 cos 2x. cos of 4x upon 2, cos of 4x upon 2. Now integrate all this. Therefore 1 by 4 integral of 3 by 2 is 3 by 2x. Integral of cos of 2x is sine of 2x upon 2 plus sine of 4x upon 4, and here is a 2. And the lower limit is 0, upper limit is pi by 2. Now take, that is here is a 1 by 2 as common. Then this 1 by 4 and 1 by 2, that will become 1 by 8. Substitute the value x is equals to pi by 2. That is 3 into pi by 2. 2 into sine of 2 into, that is in pi by 2. Plus 1 by 4 sine of 4 into pi by 2. Lower limit is 0. Replace x by 0, 0, 0. Here is 0. Now see this here 1 by 8. And that is a 3 pi by 2. What about here? 2 get cancelled. You will get sine 0, and the value of sine 0 is 0. Again here is a, that is a sine of 2 pi. What about the sine of 2 pi? That is 4 into pi by 2 means what? Sine of 2 pi, and sine of 2 pi is 0. Here is 0, and overall here is also 0. That is 1 by 8 into 3 pi by 2, and that is a 3 pi upon 16. And therefore I is equals to 3 pi by 16, the answer. Now the problem number 10. I is equals to integral minus 4 to 2 dx upon x square plus 4x plus 13. Again very simple. Now this x square plus 4x plus 13 can be written as in the quadratic form. That is x square plus 4x plus 4. This is the perfect square. It's a perfect square of x plus 2 bracket square. But here is a 4, but we have given the 13, and here is written as plus 9. Therefore integral minus 4 to 2 dx upon x plus 2 bracket square plus 9. Therefore now the integral of this, it is of the tan inverse form. That is the integral tan inverse. That is a 1 by 3. That 1 upon a tan inverse of x plus 3 upon 3. Lower limit is minus 4, upper limit is 2. Now again substitute upper limit minus lower limit. Here is a square, 1 by 3 tan inverse of x upon a. What is x here? X plus 2. A means 3. Now substitute x is equals to 2. That is 1 by 3 tan inverse of 2 plus 2 upon 3 minus tan inverse of minus 4 plus 2 upon 3. That is the tan inverse of 4 upon 3 minus tan inverse of minus 2 by 3. And that's why that is 1 by 3 tan inverse of 4 upon 3 plus tan inverse of 2 by 3. Tan inverse of minus theta is a minus tan theta, and this minus minus will become plus. And hence answer is 1 by 3 tan inverse of 4 upon 3 plus tan inverse of 2 upon 3. Now the problem number 11, that is I is equals to integral 0 to 4 dx upon in under root of 4x minus x square. Whenever there is a minus sign for this x square, always take minus sign as a common. Now here we will take the minus sign is common, that is the integral 0 to 4 dx upon in under root of minus in bracket x square minus 4x. And therefore I is equals to integral 0 to 4 dx upon in under root of, that is the same thing is here, 0 to 4 dx upon in under root of x square minus 4x. What about here second term? Second term will be the 4. How it is 4? Second term will be the 4, the middle term is 4x. Middle term divided by 2, then you will get 2. 2 square means what? 4. Actually here we are subtracting 4 to balance this minus 4. Here is a plus 4. Therefore integral 0 to 4 dx upon in under root of 4 minus in bracket x square minus 4x plus 4. X square minus 4x plus 4 is a perfect square of x minus 2 bracket square. Therefore integral 0 to 4 dx upon in under root of 4 means what? 2 square minus in bracket x minus 2 bracket square. And this is nothing but the sine inverse in bracket x minus 2 upon 2. Lower limit is 0, upper limit is 4. Now substitute, that is a replace x by 4 and x by 0. Upper limit minus lower limit. Therefore sine inverse of 4 minus 2 upon 2. 4 minus 2 means 2 upon 2 is 1. Sine inverse of minus 1. What about the sine inverse of minus 1? That is the minus pi by 2. And therefore here is a sine inverse of 1 is pi by 2 and sine inverse of minus 1 is minus pi by 2. You have learned these values in the 11th standard. That is a minus in bracket minus pi by 2. That is a pi by 2 plus pi by 2. Then you will get here is a pi, and hence the answer is I is equals to pi. Now the next problem, that I is equals to integral 0 to 1 dx upon n under root of 3 plus 2x minus x square. 0 to 1 dx upon 3 in bracket. Now from these two terms take as a minus sign as common. म्हणजे हा मायनस एक्स स्क्वेअर प्लस एक्स स्क्वेअर झाला पाहिजे. त्यासाठी या दोन्ही टर्म्स मध्ये आपण मायनस साइन कॉमन काढतो. This is the special type of the integral again. That is 0 to 1 dx upon in under root of 3 minus in bracket x square minus 2x. Again, this is the middle term. 2x is the middle term. What about the second term? That is the middle term divided by 2. Then you will get the second term as a 1. Therefore, the 3 plus 1 minus in bracket x square minus 2x plus 1. Here we are adjusting the plus 1 and here is a minus 1. 3 plus 1 is a 4. That is integral 0 to 1 dx upon in under root of 4 minus in bracket x minus 1 bracket square. That is the integral 0 to 1 dx upon in under root of 2 square minus x minus 1 bracket square. Now again, this is a standard integral, standard integral. Integral dx upon a square minus x square, which is a sine inverse of x upon a. Therefore, this is the sine inverse of x minus 1 upon 2. Lower limit is 0, upper limit is 1. Put x is equals to 1. That is sine inverse of 1 minus 1 upon 2 minus sine inverse of 0 minus 1 upon 2. Sine inverse of 0 minus sine inverse of minus 1 upon 2. Sine inverse of 0 is 0 and the minus sine inverse of minus 1 upon 2. Sine inverse of minus 1 upon 2, that is nothing but the sine inverse of minus sine of pi by 6. Here again, that is a sine inverse of sine of minus pi by 6, and that is nothing but the minus in bracket minus pi by 6, which is the pi by 6, and hence I is equals to pi by 6. Now the next problem, problem number 13. I is equals to integral 0 to pi by 2 x sin x dx. Now again here we will integrate this product of the two functions, and the first is by Lie order by the Lie. The first function is algebraic and second is trigonometry. Therefore by parts. The first function into integral of the second minus integral derivative of the first into integral of the second. That is x into integral of the sine, which is the minus x cos x, 0 to pi by 2 minus 0 to pi by 2. Integral derivative of x is 1, integral of sine x is minus cos x. And that's why here is a minus pi by 2 cos of pi by 2 plus. That is upper limit minus lower limit. Minus pi by 2 cos of pi by 2. What about the lower limit is 0? Minus will become plus. Plus 0 cos of 0. That is the cos of 0 is 1. But the 0 into this one, that will become 0. Cos of pi by 2 will be 0. 0 into minus pi by 2 will be 0. Therefore, this whole will become 0 here. Now again here minus and minus will become plus. That is, here is the integral 0 to pi by 2. What about the integral of the cos of x? Integral of cos x is sin x. Lower limit is 0, upper limit is pi by 2. And again the upper limit minus lower limit, sin of pi by 2 minus sin 0. What about the sin pi by 2? Sin 90 is 1, sin 0 is 0. Therefore 1 minus 0 is 1, and hence its value is 1. I is equals to 1. Now the problem number 14. Integral 0 to 1 x tan inverse of x dx. X is algebraic, tan inverse of x is inverse function. 0 to 1 tan inverse of x dx by parts. Again, the Lie, the first is inverse. First is inverse, then the first function into integral of the second. Tan inverse of x, integral of x, 0 to 1 minus integral derivative of the tan inverse of x into integral of x dx bracket completed into dx. Therefore, here is the tan inverse of x. Integral of the x is x. X is x square upon 2. Integral of this x is x square upon 2 tan inverse of x 0 to 1 minus derivative of the first function, integral 0 to 1 derivative of the first function. What is the derivative of tan inverse of x? 1 upon 1 plus x square. Integral of x is x square upon 2. That is a minus 1 upon 2 integral. X square plus 1 minus 1. Again, to find out the integral of this, split up this. That it can be written as x square plus 1 upon 1 plus x square. 1 plus x square, 1 plus x square get cancelled. You will get in bracket 1 minus 1 upon 1 plus x square. And here is a 1 minus 1 upon 1 plus x square. And here is a tan inverse of 1. What is the value of tan inverse of 1? Tan inverse of 1 is pi by 4. that is 1 upon 2 into tan of pi by 4 minus 1 upon 2 integral 0 to 1, and that is x square plus 1 upon x 1 plus x square is 1 minus 1 upon 1 plus x square dx. Therefore integral of, again this 1 is x, and the integral of 1 upon 1 plus x square is a tan inverse of x. Lower limit is 0, upper limit is 1. Here is a pi upon 4 into 1 upon 2, that is a pi by 8 is continued here, minus 1 upon 2. That is integral of 1 is x, upper limit minus lower limit. Upper limit is 1, that is x is replaced by 1, tan inverse of 1 minus x is replaced by 0, 0 minus tan inverse of 0. And you will get here is a 0, or all it is 0. 1 minus tan inverse of 1 is a pi by 4, that is a pi by 8 minus 1 upon 2. This minus and minus will become plus, that is a pi by 8. Pi by 8 plus pi by 8, that is a 2 into pi by 8. Then you will get pi by 4 minus 1 upon 2. Therefore, I is equals to pi by 4 minus 1 upon 2. Now the problem number 15, I is equals to integral 0 to infinity x into e raised to minus x dx. It is algebraic and the exponential. Again by the Liet, algebraic and the exponential by parts. First function into integral of the second, integral 0 to infinity. Integral 0 to infinity, derivative of the first into integral of the second. What is the integral of e raised to minus x? Integral of e raised to minus x is e raised to minus x upon minus 1. Lower limit is 0, upper limit is infinity, minus integral 0 to infinity. What about the derivative of x is 1? E raised to minus x, e raised to minus x. Integral of e raised to minus x is e raised to minus x upon minus 1 dx. Now again here substitute upper limit minus lower limit. Upper limit is infinity, that is a minus infinity into e raised to minus infinity. Lower limit is 0. That will become here 0. Whole is here. What about here? Here is a minus sign. Again the integral of e raised to minus x is a e raised to minus x upon minus, and that minus minus will become plus. Again substitute upper limit minus lower limit. E raised to minus infinity minus e raised to 0. Now what about the value of this? That is minus infinity upon e raised to minus infinity, and this whole quantity will become 0 minus 0. And e raised to minus infinity means what? 1 upon e raised to infinity means 1 upon very large quantity, and that's value will become 0 minus 1. Minus in bracket minus 1, that will become plus 1, and hence the answer is 1. That is a I is equals to 1. In this way, in this video, I had completed the properties of definite integral, and the question number 1 had fully covered. Now we will see remaining question we will see in the next video. Till then, goodbye.